Okay, this is exam 2, page 3, section 2. And I didn't write down the question, so it's here. For the first one, 1A, use the definition of the derivative with the limits difference quotients to prove that this equation is proven. So this is the definition of the derivative. And then from there, you're going to want to find your f of x and then your f of x plus h. So using this equation, f of x is equal to the square root of x plus 3. And then the f of x plus h is equal to the square root. You're going to replace x with x plus h and then plus 3. And then after that, you're going to put it into with the limit, and you're just going to substitute these values. So limit as h approaches 0, it'll be the square root of x plus h plus 3, and then it'll be minus the square root of x plus 3. And then that will all be over h. And then we want values to cancel, so we're going to multiply this, but with a positive to cancel it out. So then it'll be multiplied by square root x plus h plus 3, but this time it'll be plus the square root of x plus 3, and then it'll be the exact same thing on the bottom, x plus h plus 3 plus the square root of x plus 3. And then these values can cancel, and then these two, they'll cancel out, and then this will equal, carry the limit, as h approaches 0, and then it's going to be all of these square roots will cancel out, so you'll just be left with x plus h plus 3, and then, x plus h plus 3, it'll be subtraction, and then it'll be x plus 3. And this will all be over. All of this will stay because h multiplied by this is going to be one big equation. So it's going to be this in parentheses, square root x plus h plus 3 plus the square root of x plus 3. And then after that, the h's can cancel. Not yet. This will, you're gonna try to get the h to the top, and you're gonna be left with this whole thing, same exact thing, but h over, and then it'll be all the same. H square root x plus h plus 3, and then plus square root x plus 3. And then here is when the h's can cancel. This will become 1. And then you're left with this equation. You're going to be able to factor out and simplify. So then, moving on, you're going to get the limit as h approaches 0. And you're going to be left with, oh, actually, I don't need to do the limit anymore. No more limit, because I'm going to be plugging in 0 for h for this value. This would be 0, so it'll equal 1 over, and then it'll just be square root x plus 3, and then it'll be plus the square root of x plus 3, and this simplifies to 1 over 2, and then the square root of x plus 3. So that's your final answer. And then moving on to part B, it says find the equation of the tangent line at x equals 1 for f of x is equal to the square root of x plus 3. So we're going to start off by, this is going to be our equation. We're going to find our values and then plug it into here so that we can get an equation. We're going to start with f of 1, trying to find f of 1. So f of 1 is going to be 1, the square root of 1 plus 3, which is the square root of 4, which equals 2. And then we're going to find f prime of 1, and this will be 1 over, and then it'll be still, that's the derivative, so it'll be 2 of 4, and then that is going to equal 1/4, and this will be the slope. And then after that, we're just going to plug everything in and simplify, because now we have our point as well. It's going to be 1, 2. So it'll be y minus 2 equals 1/4, and then it'll be x minus 1. And then what you're going to do, you're going to distribute the 1/4. So, and then you're going to add this over here. And then you're going to end up with y equals 1/4 x. And then if you do 1/4 plus 2, that'll be technically 8/4. And then you'll subtract 1/4 from the 8/4. And then you'll end up with plus 7/4. And then that should be your final answer.